This video covers the adapter pattern and a few variations of it. I'll start with the classic pattern, which relies on classes, but then I'll show you how to take this a step further by taking the idea of the pattern and using modern Python features to achieve the same thing, but with less code. And we all like less code, right? Knowing some of these design patterns is quite useful, as they're great tools to help you improve the design of your software. They reduce coupling and make it easier to change or extend your code. If you want to learn more about how to design a piece of software from scratch, I've written a free guide to help you. You can get this at ArjanCodes.com/design guide. It describes the 7 steps that I take when I design software. I think you find it helpful in structuring the way you approach software design. So ArjanCodes.com/design guide. The link is also in the description of this video. Now, let's take a look at today's example. Today's example loads configuration settings from a JSON file and then runs a fake experiment with them. There are a couple of files here. I have the main file, which simply has a main function. It imports an experiment class from the experiment file. It opens a config.json file, loads the JSON data, creates an experiment, and then runs that experiment. Now, the config file contains just a few basic settings, which are commonly used in machine learning projects like epoch count, batch size, log path, etc., etc. The actual values here are not really that important. It's more about how the config is loaded. And if you look at the experiment, there's also not much happening here. It's a simple class that has an initializer that gets a configuration that it stores as an attribute. Then there are a couple of methods for loading data and setting up things, and this uses the config to set things up. The class is not actually doing anything meaningful, it's just printing out things. But you can imagine that if you have a real machine learning project, that this would be how you would set up things. And then in the end, there is a run method that then calls those methods. And as you can see, we call that method again from the main file. When I run this code, it just prints out a few messages. And you can see that it actually read those config values like raw data and runs and the number of epochs from the configuration file. At the moment, this is using a JSON file for reading configuration data. But suppose you want to read it from another type of file, like an XML file. You might use another library for that, like Beautiful Soup, which is commonly used to extract data from websites or read XML files. That's what it can also do. But the way you get the data from Beautiful Soup works differently from how you get it from a JSON file. JSON basically gives you a dictionary. With Beautiful Soup, you have a class that has getters for specific keys to get the values. So if we wanted to replace the JSON file here with an XML file and use Beautiful Soup, it means we'd have to then manually convert that into a dictionary so that it works with experiment, or we'd have to adapt the experiment class so that it can accept something that's a bit more generic. This is where the adapter design pattern can be helpful. It's going to provide an interface between, let's say, an XML reader like Beautiful Soup or a JSON reader and the experiment class that is going to use the information that comes from that configuration. The goal of the adapter pattern is to adapt an existing system so you can use it in your application. You do this by creating a layer, that's called the adapter, between that existing system and your own code. It's a bit like when you have something that has a micro USB input used for charging, but you only have a USB-C charger. The connector doesn't fit, but you can use an adapter that you put between the USB-C connector and the micro USB input. That's what the adapter pattern does, but then in software. There are 2 versions of the classic adapter design pattern, an object-based version and a class-based version. In the object-based version, which honestly I think is the better solution, you're relying on composition. So what happens, I have a mermaid diagram here that I can show you. We have a client, well, in our case, that would be the experiment. The experiment uses some kind of target on which it performs an operation. In this case, the operation would be to get a configuration value. And we have an adapter that implements that specific operation. And then we have the adaptee, that's the thing that's being adapted from. So if we were extending this experiment system to allow for XML reading using Beautiful Soup, the adaptee, that would be Beautiful Soup. We would build an adapter that would have a standardized way of getting a configuration setting that's implemented for Beautiful Soup. And then the client, the experiment in this case, would then use that generalized way of accessing the information. And then if you have another thing that implements this target interface, then you can easily integrate it with the client, because this relationship here that's built using an abstraction. So that's the whole idea of the object-based version of the pattern. And in the object-based version, if you look here, the adapter has an instance of the adaptee. So if we were using Beautiful Soup, I'll show you how this works in a minute, then the Beautiful Soup adapter would have an instance of Beautiful Soup that it would perform operations on. The class-based variety of the adapter pattern is slightly different. I'm going to show you that in a minute as well, and then I'll also illustrate what kind of problem you can encounter if you use the class-based version of the adapter pattern. Here I have an XML file that contains exactly the same configuration settings as the JSON file. So we're going to use this to test our XML loading extension of the program. So the first thing that we need to do is we need to specify the adapter interface. We need to define how Experiment is going to get access to configuration settings. So what I'm going to do is I'm going to create a new file here. Let's call that config access. And this is going to be our adapter interface. So this will be a class. Let's call that config to keep things simple. And this is going to be a protocol class. So I'm automatically importing this. And inside this class, we're going to put one single method to get a configuration value. So we need get, self, and we're going to supply a key. And this is going to return, let's say any, because it can be a number, it can be a string, it can be a Boolean value, we don't know, so we use the any type. Also import that. Or if the key doesn't exist, it's going to return none. And let's add a docstring here. There we go. So that's our adapter interface. Now the fun thing is that this getter is actually exactly the same as the dictionary getter. So we don't even need to adapt the way that the dictionary works because that's already done in this way. So now let's go to the experiment. And instead of passing a dictionary here, let's pass a config object. Like so. And that we're going to get from this file. So this is config. And as you can see, the get part, it still works in exactly the same way because dictionary already has a get method like this. So when we look at the main function here, for the moment, let's try this with the JSON file. We don't have to change anything and this should work just like it worked before. So as you can see, that's exactly what happens. Let's clear this screen here. I'm going to close the JSON file here. So now what we can do is instead of reading the configuration from the JSON file, we can start implementing reading it from the XML file. And then as long as we have a class that implements the get method, now we can use it with Experiment without having to change anything in the Experiment class. So in the main file, let's import Beautiful Soup. So that's this class. And we're not going to read the JSON file. We're going to read the XML file. And then here we're just going to do file.read. That's just going to give us all the data. And now what we can do is create a Beautiful Soup instance that reads the XML data from this configuration. So we create a Beautiful Soup instance, we pass the config, and we indicate that this is going to be read using the XML parser. If you want to use Beautiful Soup in this way, you have to install both Beautiful Soup, BS4, and you also have to install an XML parser, for example, LXML. So that's Beautiful Soup. Now what we need to do is we can't simply supply Beautiful Soup to the experiment because that expects something that adheres to the config protocol. So what we need to do is create an adapter for Beautiful Soup. So I'm going to add a file here. Let's call that XML adapter. And there we're going to need to adhere to this config protocol that we have right here. So let me copy this. And I'm going to the XML adapter, paste it here, and let's call this XML config. And we don't need to inherit from protocol here. So let me remove that part. So there is a getter, gets a key, any we need to import. There we go. This is not needed. And here we're going to need to do something. I'll fill it in a minute. First, what we need to do is add an initializer. And the initializer is going to get the Beautiful Soup instance. So that's the object-based version of the adapter, where the XML config object, which is the adapter in this case, has an instance of the adaptee, which is the Beautiful Soup instance. And let's also import that. There we go. This is going to have return type none because that's the initializer. Self.bs, weird variable name, but well, we'll just have to deal with it. So we store it as an instance variable. So with Beautiful Soup, we need to get the value in 2 steps. So the first is that we're going to get the value from self.bs.find. And then we're going to provide the key, like so. So that's going to give us a value if that value exists. If not value, then we need to return none in this case. And otherwise we're going to return value.getText. So that's going to give us what's actually contained within the XML structure. Now we can make this a bit more generic because now the default value, if you can't find the element, is none. And there's no way to change that. Dictionary actually has a default. So what we can do to make this a bit more generic is add a default value here. Default value, and that's going to be any. And default, the default value is going to be none. So we can do the same thing here in the XML adapter. So we have our key and then we have the default value, and that's going to be any, and default that it will be none, like so. And now here we're going to return the default value that was passed as an argument. So this is our XML config adapter that we can put around Beautiful Soup. And now when we go to the main file again, we have our Beautiful Soup instance. We can create the adapter, which is an XML adapter. And we need to, oh, sorry, it's not an XML adapter, it's an XML config. And this is going to get our Beautiful Soup instance, and we pass the adapter to the experiments. So this is the new setup. And when we run this program, then you see it still gets the correct data. Let's change this just to test that it gets it from the right file. So let's turn this into 30. And now let's run it one more time to see what happens. And we see indeed that we're now training for 30 epochs. So this is what the adapter achieves. We didn't have to change anything in experiment. We can replace the JSON file with the XML file, and this provides a bit more flexibility. The class-based version of the pattern is slightly different. That doesn't use composition, but it uses inheritance. And this is what it looks like. You have the client. That's the experiment class in our example that uses a target and calls an operation on that. So the target is the configuration, and getting a configuration value, we have the adapter, which is the XML adapter, and we have the adaptee, which is Beautiful Soup. Here you see that there is an inheritance relationship. So adapter is actually a subclass of adaptee, and I see I actually have to swap around here the class name. So that's actually going to be this, like so. And now let's go back to the preview, and now hopefully this fixed. Yeah, so the adapter is now a subclass of adaptee, and it also implements this interface. So it does these two things at the same time. Now, how do you change the code to reflect this? Well, what we would need to do is, let me just close this file and let me close the preview as well. So I'll just go back to our XML adapter and I'll show you what you need to change in order to follow a class-based approach. So what we need to do now is, instead of passing the Beautiful Soup object as an argument to the initializer, we need XML config to be a subclass of Beautiful Soup. So that looks like this, Beautiful Soup. There we go. And now we actually don't need the initializer. So it looks simpler, but there's a problem. I'll show you what I mean. So we have the get method, and then we don't do self.bs, but we simply do self.find. So in the main file, what we now need to do is we don't create a Beautiful Soup instance. We create an XML config instance. So we pass the config here, and we pass the XML here, and then I can delete this. So if we run this code, then you see that it actually still works. But there's a potential problem here, because let me also create a Beautiful Soup instance directly. Like so, and that gets the config and the XML. There we go. And now if you look at the Beautiful Soup instance, I can call Beautiful Soup.get. So get is already a method that's in Beautiful Soup. And by overriding it with the XML config class, we change the meaning of that get method. And that might mean that other things that still rely on Beautiful Soup behaving in a certain way might actually not work anymore. So that's why the class-based version is dangerous because it mixes up the definitions and the interfaces of the original, of the adaptee, with what you want to have in the adapter. Composition cleanly separates this because the Beautiful Soup instance is part of the object via composition, and the object exposes a new interface that has a new definition that's completely separate from the adaptee definition. The idea of the adapter pattern is that it forms a layer, an adaptation layer between the existing system and your application. There's no particular reason to use a class for that. In fact, if you use a function that's partially applied, you can achieve the same adaptation, shorten the code at the same time, and boast about being a functional programming elitist. So currently our XML adapter is a separate class which has a single method get. And when you look at experiment, actually the only thing it does is call this method. It doesn't use a bunch of other methods in this class. So you can also argue that it might be cleaner to actually provide a function to the experiment class instead of an object, because it will really simplify things. So what you can do, for example, is instead of using this config object that we have here, we could provide a function that accepts a key and it's going to return a value. And let's define an alias for this function. So let's call this a config getter. And this is going to be a function, so that's a callable in Python. And this will get a string as an argument. And this is going to return any or none. That's the result of the function call. And now instead of a config object, we're going to provide experiment with a config getter. And that's of type setter, no, getter, config getter. And then let's also change the names here. So this is a config getter. And of course here we also have to change this to, man, I have to learn to type again, config getter. Okay. And now instead of doing this, we simply call the function config getter, like so. And we will also change that here. There we go. And we will also change it here. There we go. So we have our 3 config getter calls like so. And now the config object that we have here is no longer needed. So I'll just delete that. So that's our experiment. XML adapter now becomes much simpler because we don't need this class anymore, but we can define a simple function. I'll do that in a minute. But first what I'll do is I'll show you how to adapt the example to use the original JSON file, because that actually also still works. So then this is going to be JSON again. And here we're going to import JSON. And then config is going to be read using json.load, like so. And now what we can do in the experiment is we're going to provide it, because config is now dictionary. So the getter, that's actually config.get. Let me delete these lines because we won't use them for now. So now when I run this again, of course I need to provide the file. That will probably make things a lot easier, right? So config.json works. And it works because now in the main function, we pass the method attached to the config object to experiment. And then experiment simply calls that method directly. So experiment doesn't even know that there is a config object here. It simply knows that there is a function that it can call to get a configuration value. Now, how do we change the XML adapter to also follow this same procedure? Well, first we need to delete the class because we're going to need a function instead. So I'll delete this and then select these lines, de-indent them, and let's call this get from BS. So it gets a value from Beautiful Soup. And then that doesn't need self, but it needs a Beautiful Soup instance. And then here it does Beautiful Soup.find the key. If not value, it returns the default. Otherwise, it returns the get text result. So that's get from BS. Now in the main file, let's change this again. So I have my config.xml and config, that's going to be file.load. There we go. And now we can create the experiment and we need to supply the function. So now we can create the Beautiful Soup instance. Beautiful Soup config XML. There we go. That's our Beautiful Soup instance. A minor issue is that the config getter in experiment that we have here, it expects a callable that gets a string as an argument and returns any or none. If we look at the XML adapter function, this getter here, it has a beautiful soup argument as well. So that doesn't match what we should pass to experiment. So we need a way to change the XML adapter function so that experiment can actually use this. And that's where partial functions come in. I did a video about partial a while ago. If you are interested in learning more about how partial works and how you can use it, check out the video in the link above. Now, let's import this function. So that's get from BS. And let's also import functools, because that's where we're going to get the partial operation from. What partial does is that it takes an existing function and applies arguments to it and then returns a new function where you can still apply the remaining arguments. So let's call this get from BS adapter, because we're creating a functional adapter, and that's partial. A partial application of get from BS. And we're going to supply the BS value like so. Now, unfortunately, if you look at the type hints for get from BS adapter, Pylance and Pylance MyPy, they don't really support this really well. I would like this to have the same signature as get from BS, except for the beautiful soup argument, but unfortunately that doesn't work yet, which is a pity. This is in TypeScript, this all works a bit smoother. Anyway, we now have our adapter, and our adapter has the partially applied argument PS. So it now follows the exact same structure as the getter that experiment accepts. So instead of this, we can now pass get from BS adapter. And now if we run the code, I get an attribute error. And that's probably because I didn't load the file correctly. Yeah, so it shouldn't be load, but it should be read. Let's run that one more time. And now you see we're reading again the config settings from the XML file. So overall, using this partial function approach is also a nice variety of the adapter pattern and works particularly well if you just need to adapt a single function. Then you don't have to create all those classes and interfaces, but you can keep things relatively simple. So I hope you enjoyed this video and that it helped you get a better understanding of how the adapter pattern works and what varieties you can apply to have better separation and better flexibility in your code. If you enjoyed the video, give it a like. Consider subscribing to my channel if you want to learn more about software design and development. Thanks for watching, take care, and see you next time.